The United States government just wrote a check for $66 billion to fix passenger rail. It is the single largest investment since World War II. So, why is your train still late? Why does a ticket from Washington, D.C. to New York still cost more than a plane ticket? And why are we still riding in 40-year-old metal boxes that smell like diesel and disappointment? If you think the answer is just incompetence, you are wrong. The real reason is actually a war, a hidden war against physics, geography, and corporate monopolies. To understand this war, we have to look at the hardware itself. If you put an American train next to a Japanese Shinkansen, the differences are immediately obvious, but they go much deeper than aerodynamics. In Europe and Asia, the standard for high-speed rail is the electric multiple unit, EMU. On these trains, there is no massive locomotive at the front doing all the pulling. Instead, small electric motors are distributed underneath the body of almost every car. This gives the train incredible traction and acceleration. It allows them to climb steep hills and, perhaps most importantly, keeps them light. Because these trains run on dedicated tracks where there is zero risk of hitting a heavy freight train, they can be built like aircraft, using lightweight aluminum alloys designed for speed. The American approach is completely different. Outside of the Northeast Corridor between Boston and D.C., our rail network is almost entirely unelectrified. That means we rely on the diesel-electric locomotive. These are engineering marvels in their own right, essentially a giant diesel generator on wheels that powers electric traction motors. But they are heavy, loud, and by definition, they cannot achieve the instantaneous acceleration of an electric train powered by the grid. You might ask, why don't we just electrify the tracks? The answer lies in what else uses those tracks. American freight railroads rely on double-stack container cars, which are very tall. Hanging overhead electric wires called catenary systems is incredibly expensive and often interferes with the vertical clearance needed for these massive freight loads, so we are stuck with diesel. But the biggest difference is not the fuel, it is the weight. For decades, the Federal Railroad Administration enforced safety regulations that were fundamentally different from the rest of the world. Because American passenger trains share the tracks with massive freight trains, the government required passenger cars to be built like tanks. They had to meet buff strength requirements, meaning the frame of the train had to be able to withstand 800,000 pounds of force without crumpling. This philosophy was based on crashworthiness. The idea that since we cannot prevent crashes, we must build trains that can survive them. While European engineers were designing crash energy management systems, essentially crumple zones like you have in your car, American engineers were adding steel reinforcement. The result? American trains became incredibly heavy, and in the world of physics, weight is the enemy of speed. Heavy trains take longer to accelerate, longer to stop, and they punish the tracks they run on, leading to higher maintenance costs and bumpier rides. The good news is that the regulators have finally updated the rules. We are seeing a shift toward the European standard of accident avoidance rather than just accident survival. This is why Amtrak is finally ordering new fleets like the IRO train sets. These are lighter, modern trains that use crumple zones, but replacing an entire nation's fleet takes time. And for now, we are still largely moving heavy iron. However, even if you build the lightest, fastest train in the world, it is useless if you don't own the road it drives on. And this brings us to the single biggest obstacle in American passenger rail, the host railroads. This is the one structural problem that money alone cannot fix. In France, the national rail operator owns the tracks. In the US, Amtrak owns just 3% of the 21,000 miles it travels on. The rest is owned by private freight giants like Union Pacific, BNSF, and CSX. Legally, Amtrak has the right of preference. A law passed in 1973 states that if a passenger train and a freight train meet, the passenger train goes first. But in practice, this law is toothless. The Department of Justice rarely enforces it, and the fines for delaying passengers are a rounding error for these multi-billion-dollar freight corporations. To make matters worse, the business model of freight rail has changed. Over the last decade, the industry adopted a strategy called Precision Scheduled Railroading, PSR. The goal of PSR is to maximize profit by moving more cargo with fewer crews and fewer engines. The result is the monster train. 20 years ago, a freight train might have been a mile long. Today, it is not uncommon to see freight trains that are 3 miles long. This creates a physical geometry problem. Most of the sidings, the parallel tracks where one train waits for another to pass, were built decades ago and are only about 1.5 miles long. When a 3-mile-long freight train enters a section of track with sidings that are only 1 mile long, it literally cannot pull over. It becomes a moving wall. If an Amtrak train comes up behind it, it has to wait. If an Amtrak train is coming the other way, it has to pull over and wait, sometimes for hours, for the monster freight train to crawl past. This is why the long-distance routes, like the California Zephyr or the Empire Builder, often have on-time performance ratings below 50%. You are not late because of incompetence on the part of the Amtrak crew. You are late because your landlord does not care about the tenant. The freight railroads argue that they are running a business and that the rail network is private property. They are not wrong. They pay for the maintenance, they pay the taxes, and their primary obligation is to their shareholders, not to a passenger trying to get to grandmother's house. This fundamental tension, public service running on private infrastructure, is the knot that America has never been able to untie. So, if the hardware is heavy and the tracks are rented, why are we suddenly optimistic? Because for the first time, the United States is trying to engineer its way out of these traps. The $66 billion from the infrastructure law is not just a slush fund, it is being targeted at specific bottlenecks that have held the system back for 50 years. The most critical project is the Gateway Program. Right now, the entire rail economy of the Northeast, which supports 20% of the nation's GDP, relies on a single pair of tunnels under the Hudson River that were built in 1910. These tunnels are crumbling, damaged by seawater from Hurricane Sandy. If they were to fail, rail travel between D.C. and New York would effectively stop. Billions of dollars are now flowing to bore new tunnels and to repair the old ones. It is unsexy, invisible work. You will not see it on Instagram, but it is the difference between a functioning system and a collapse. We are also seeing money flow to the Frederick Douglass Tunnel in Baltimore. The current tunnel dates back to the Civil War era. It is so old and has such tight curves that trains have to crawl through it at 30 miles per hour. Fixing these single points of failure won't make the train go 200 miles per hour, but it will make sure the train actually arrives. But the most exciting shift is not coming from the government. It is coming from the private sector. We are witnessing the rise of a new model, the private passenger railroad. Brightline has effectively done the impossible in Florida. They built a higher-speed rail service that connects Miami to Orlando. But the genius of Brightline was not the train. It was the business model. Brightline realized that a railroad is not just about transportation. It is a real estate play. They bought land around the stations, built luxury apartments and offices, and used the train to increase the value of that land. By owning the real estate, they subsidized the cost of the rails. Brightline runs at 125 miles per hour, faster than most Amtrak trains, and they have proven that Americans are not genetically predisposed to hate trains, they just hate bad trains. When you offer a clean, reliable, fast service, people will pay for it. This success has emboldened them to try something even bigger, Brightline West. This project is currently under construction and aims to connect Las Vegas to Southern California. Unlike the Florida route, which upgraded old freight tracks, this will be brand new. The brilliance of Brightline West is where they are putting it. Building new train tracks in America usually involves a nightmare of land acquisition, buying up hundreds of private farms, and fighting hundreds of lawsuits. Brightline West circumvented this by striking a deal to build their tracks in the median of Interstate 15. The land was already there. The environmental impact is minimal because it is already a highway corridor. They are aiming for speeds of 186 miles per hour, making it the first true high-speed rail in America. And because they are a private company racing to open before the 2028 Olympics, they are moving at a speed that makes government projects look glacial. Speaking of glacial government projects, we have to address the elephant in the room: California high-speed rail. For years, this project has been the punching bag of American infrastructure. It is billions over budget and years behind schedule. Critics call it the train to nowhere because the first segment connects the Central Valley cities of Merced and Bakersfield, rather than San Francisco and Los Angeles. The struggles of California high-speed rail are a masterclass in how difficult it is to build in America. They did not have a highway median to use. They had to negotiate with thousands of individual farmers and landowners. They faced environmental lawsuits from every angle. They had to build massive viaducts over active freight lines and highways. However, even here, the narrative is shifting. The concrete is poured. The viaducts are rising across the Central Valley. While the dream of a quick ride from San Francisco to Los Angeles is still far off, the initial segment is going to open. It will likely serve as a test bed, proving that high-speed rail technology can work on American soil. It will be the first place in the United States where you can ride a train at 220 miles per hour. It is an expensive lesson, but the infrastructure is finally becoming real. So where does this leave us? If you are waiting for a European-style network where you can take a high-speed train from Des Moines to Denver, that is never going to happen. The geography and population density just do not support it. The United States is not France. It is a continent-sized country with cities spread hundreds of miles apart, but we are moving toward a hybrid model. In dense corridors, such as the Northeast, Florida, California, the Texas Triangle, and the Midwest hub around Chicago, we are slowly building a modern, reliable network. The trains of the future, like the Amtrak Arrow and the high-speed Brightline cars, are finally entering production. The era of managed decline is over. We are in the era of growing pains. It is going to be messy. Construction causes delays. New trains have teething issues, and the fight with freight companies regarding track access will likely end up in the Supreme Court. But for the first time in our lives, the arrow is pointing up. We are not trying to copy France anymore. We are building an American solution, one that has to handle monster freight trains, vast distances, and a century of neglected infrastructure. It might not be perfect, and it certainly is not cheap, but the sleeping giant of American rail is finally waking up.